Okay, this lecture is over Module 12 from the curriculum entitled WLAN Concepts. Of course, WLAN, when we put W's in front of things like that, mean wireless. So we're going to learn about LANs that include wireless devices or that are comprised of wireless devices. First section, why should you take this module? To understand wireless LANs and some of the concepts associated with wireless LANs. In particular, what will you learn in this module? We'll learn about wireless technology and standards. We'll talk about the different components that you may have in a wireless LAN. We'll talk about how wireless LAN operates. We'll talk about CAP, WAP, and WLAC, which is wireless LAN controllers, protocol and device that you use to manage multiple APs, which again, I think we talked about this previously, but AP stands for access points. Wireless networks have different frequency channels. We'll talk about those channels and the management of those. We'll talk about threats to a wireless network, and we'll talk about how to secure wireless networks. So, rather lengthy list of things that we're going to talk about in this module. So, as far as the intro to wireless, the first thing they talk about is the benefits of wireless, and there's really two big ones. The first is convenience. You don't have to find cables or carry cables with you. You can just open your device or power your device on and connect to a wireless network, move around, that type of thing. If you have 10, 20 people in a conference room, you don't have to have the 10 or 20 wired connections for people to connect to. You can put a wireless access point in there. And the other big advantage is cost savings. So putting a wireless access point to service those 20 people in a conference room is probably going to be cheaper than buying the switch or two that you need to connect those, run the wires, have the connections built into the furniture or the room. So cost savings is a big benefit of wireless as well. So I don't particularly like this, but all the different types of networks that we've talked about in the past, if you simply put W in front of it, it's the same type of network, but it's built wirelessly. So the first one they have is a wireless personal area network. Again, the stereotypical classic example we give of a personal area network, something that's within 20 or 30 feet of each other or that distance from yourself, is Bluetooth. A wireless LAN is a local area network built on wireless. So we have an access point that is connected to a switch or a hub, connected to an internet connection. And then there's lots of different devices that can connect wirelessly. Here we have phones, tablets, laptops, displays, and printers are some of the popular ones that are connected to a wireless LAN. The next one is a wireless metropolitan area network. So these are things that are typically in a city, semi-close to each other, maybe a block or two away from each other. And instead of running connections between all the buildings, you have connectivity via wireless. And then we have a wireless WAN or wide area network. And typically this is going to be covered over an extensive geographic area and will be done with satellite or something similar. So those are the different types of wireless networks that we can have. Next, they're talking about actual technologies. So Bluetooth is low energy personal area network, again, typically 20, 30 feet from each other. Cars have Bluetooth, speakers can use Bluetooth. We have wireless headsets that are Bluetooth, etc. So there are different things that we can connect using Bluetooth. The next is WiMAX, which is Worldwide Interoperability for Microwave Access. I looked, and I may have you look in a future assignment, but I did find a Kentucky WiMAX that covered Harrodsburg, Danville, Perryville, and Springfield, were some of the larger cities that they mentioned. So we do have WiMAX in Kentucky. You can have cellular broadband. This is where you use your cell connection to do cellular internet. If you have a smartphone, you probably have this enabled and use it. 4G is kind of the current standard. 5G is a standard that is coming. It is supposed to be 5 to 20 times faster than 4G. And kind of the humorous thing I put in here is 5G does not cause or propagate COVID-19. There are a group of people that say that the installation of 5G cellular broadband is what's causing COVID-19, which of course is not true. And then we have satellite broadband, where we are getting internet connections from satellites. This has been around for a while. I first ran into it at Comdex in the probably late 90s or very early 2000s. Hughes Aircraft was hyping a box that you could connect to a satellite dish, and any computer could connect to the internet. So I looked at the box, and instead of having an RJ45 Ethernet connection, it had a USB connection. So I was like, oh, cool, I can connect my Mac to this to the internet? And they're like, well, anything except a Mac. And then I was like, oh, cool, so I can connect my Unix machine to it? Well, no. And I was like, okay, so every machine in the world means every Windows machine in the world. And by the way, if you had made this an RJ45 jack, you could actually really say any computer in the world. And the guy was kind of annoyed with me because of that. A little more recent example, I don't know if you've been following this or not, but SpaceX is trying to make a worldwide mesh network to provide broadband to at least the populated portion of the world. They're launching on 50 or 60 at a time. And I know there's been at least 2 launches. There may be more. So they're slowly going through and trying to make satellite broadband very widely used. Okay. The next section talks about IEEE 802.11. I think I've talked about this early on, but IEEE is the Institute of Electrical and Electronics Engineers, and they do a lot of standards related to computers and networking. They have a standard 802, which is for computer networking. Several years ago, I said, I'm sure there's an IEEE 803, and I'm sure it has nothing to do with computer networking. And somebody looked it up and said it was a standard for how to name things in a power plant. So IEEE does a lot of standards, some related to computer and networking. 802 is computer networking. 802.3 is basically Ethernet. And 802.11 is wireless. So when the standard came out, it was first simply called 802.11. And as we can see down here, it used the 2.4 gigahertz range, which unfortunately is the same range as some cordless phones, which can cause problems. And the speed was up to 2 megabits per second, which when 802.11 came out was really, really good. By today's standards, not so much. So then 802.11a came out. It had a smaller area that it covered, but it offered speeds up to 54 megabits per second. It's 5 gigahertz range. 802.11b came out. It's 2.4 gigahertz range. It had speeds up to 11 megabits per second and had a longer range than 11A did. Then G came out, 2.4 gigahertz range, speeds up to 54 gigabits per second. Backwards compatibility with 11B. Then 11N came out. It uses 2.4 and 5 gigahertz. It can offer data transfer in the 150 to 600 megabits per second, which is quite a bit. Distance range up to 230 feet, which is not horrible. For example, that would cover a big chunk of a building or most homes. It is backwards compatible with 802.11a, b, and g. Then 802.11ac came out, 5 gigahertz range, 450 megabits per second up to a gig per second, which is kind of the speed we're trying to hit these days with fiber. It can support up to 8 antennas, and it is backwards compatible with 11A and 11N. And then released in 2019, we have 802.11ax. It uses both the 2.4 gigahertz and 5 gigahertz range. It has higher data rates and improved power efficiency. They don't really tell the speed, probably because it's not in super wide use yet. Now, earlier I mentioned frequency, so you might have studied this in physics. We have something from radio waves all the way through X-rays and gamma rays. Around the ultraviolet range, there's a very thin slice that we see as visible light from red to blue. We know what X-rays are. Gamma rays or radiation basically can cause problems. We had infrared devices such as infrared remotes, microwaves, and then radio waves. TV falls in here as well. So we have different frequencies that we can use. And like I said, the 2.4 gigahertz and 5 gigahertz are the two most popular for wireless networking. Now earlier I mentioned the IEEE, which we have here under standard organizations. We talked about that. But we also have the ITU, the International Telecommunications Unit, and they give out the different frequencies or control the radio frequency spectrums, and they also dictate satellite orbits for the ITU. And then we have the Wi-Fi Alliance, which is a nonprofit organization that is responsible for evaluating and kind of giving a stamp of approval to Wi-Fi devices to say that they conform to various standards correctly. 1217 is a check your understanding on the basics of wireless. You can do that on your own, and we will move on to WLAN components. So I think I will play this first video. It's about 6 minutes and 12 seconds, but I will play it here in line with the lecture.
Hello everyone, we are here to talk about wireless LAN components. And with wireless LAN components, I've got a table full of items to bring up. To get started, let's start with the end device and the network device you're connecting to. An end device is going to have a transmitter, receiver, antenna inside of it. Here we have a laptop. And when the laptop screen is open, that antenna is right up here at the top of the laptop screen. Gives you better signal strength and connectivity. That's going to be an integrated internal antenna up there. In comparison, what if you're running a desktop computer and maybe your desktop computer doesn't have wireless? Well, what you can do is purchase a card like this that would connect to your motherboard, and with that card, it can have an external antenna off the back of your desktop tower. This antenna is known as a dipole antenna. It's omnidirectional, but we'll get to that later on. Now, besides antennas like this that are going to be literally integrated into your motherboard by purchasing and installing, you can also purchase USB antennas. For example, there's an internal wireless antenna inside of this, and it's got a USB cable that would plug into your machine. There's also other variants where we have a USB adapter with a wireless antenna built in, and again, it's got a little dipole antenna there for omnidirectional wireless coverage. So that's going to be our end devices that are going to interconnect with now the network devices. And with these network devices, one of the common items we'd see is the wireless router. And the wireless router here is going to provide network connectivity for those end devices as they want to communicate. Now, these wireless routers commonly have three functions. Those three functions being, number one, a switch built in. For example, I've got a set of blue ports here. There are 4 of them. That's an integrated switch in this wireless router. You plug your wired devices into that switch. Why? Because the wireless router has another function, which is function number 2, and that would be an internet port, which is the function of default gateway/router. The function means we're going to be able to send our wired network traffic and wireless traffic out to a different network or infrastructure. That could be the internet, for example, off of that internet port. The third and final function of this wireless router is we have internal integrated antennas in this wireless router, which allows us to connect our wireless end devices. There's other wireless routers that are out there too. For example, like this one, it does not have internal antennas. All the antennas are external, but same thing. Switch built in, internet port as default gateway, and wireless services provided. So as we talk about these wireless routers, what are they going to do on the wireless side of the house for us? Well, this wireless router is going to be broadcasting what's known as a beacon. And a beacon is going to include the SSID, which is a service set identifier. That is the name of the wireless network you want to connect to. So when you're looking on your phone or looking on your laptop and you click refresh for those wireless networks, it's going to see the SSID, which is the wireless name of the router. These wireless routers also do association and authentication, and what that means is when you refresh and receive that beacon, not only will you get the wireless name, but you're also going to see the security standards and wireless standards supported by that access point or wireless router. That allows you to associate and authenticate successfully and communicate with those wireless devices. Let's dive in a little bit deeper now. We have the wireless router covered, but what if you want to deploy many wireless devices on your network and extend wireless range? One of the first things people like to say is go with a range extender. A range extender can only do so much regarding distance and also doesn't scale well. The other solution is to deploy a wireless access point. Looks just like a wireless router. The wireless access point has one major function, and this is one network port on the back. It's not running as a switch. It's not running as a default gateway. The wireless access point is going to connect to your wired infrastructure and connect wireless devices using its antennas. These are awesome. There's 2 classifications we want to get into. We're going to have autonomous wireless access points, where each wireless access point you deploy requires full configuration by you. Imagine having 100 of these to provide network and wireless access across a big business. That would take a while. There's a other solution to go with besides autonomous, and that's called controller-based. With controller-based access points, they're commonly called lightweight access points. These access points, they again have maybe 1 or 2 ports. This one has 2, a primary network port and a backup in case the primary goes down. But these lightweight access points that are controller-based do not require individual configuration of each access point. You configure a wireless LAN controller, a WLC. And when you configure that controller and you plug these into the network that the controller is on, the wireless controller will configure and manage all of your lightweight access points. Another version, of course, is this big beefy Cisco one right here. Same thing. Deploy 10, 20, 30, hundreds of these wireless access points. They are controller-based, which means they're all managed and configured by the wireless controller without initial configuration. Doesn't scale so well? Scale's awesome. So last but not least, let's hit some antenna types. I mentioned we get to it. We have all these wireless devices, and we hit this already. These are those dipole antennas, which provide 360 degrees of coverage. They're awesome when you're talking about rooms and small areas of hallways, but they're not going to go long distance. So if you want to go long distance, what we'd focus on is something more akin to this. And these type of antennas are not omnidirectional. These type of antennas provide directional-based coverage. There's different versions like Yagi and parabolic, some that look like radar dishes. They're meant to target longer range distance with wireless technology. So these are our wireless LAN components. Take your time and study and read and have some fun.
Okay, we'll continue on and talk about some of the components that were talked about in the video. The first is a wireless NIC. When we talked about NICs, network interface cards, we are often talking about an RJ45 jack that's either built into the motherboard or on an expansion card inside our PC. But in the case of wireless, we need NICs that are able to communicate on the radio frequencies specified and send digital data over the wireless connections. These days, when laptops first started out, they almost always had an RJ45 jack or a telephone jack. Then those have disappeared over time, primarily to make the devices thinner, and have been replaced with wireless cards. Our tablets have wireless cards. Our smartphone have wireless cards or wireless NICs. Even some cars have wireless NICs. Airplanes have Wi-Fi on them as well. So those are different ways we can connect to a wireless network. Here they're talking about what they're calling a home router. Most often in Cisco 1 and in, for example, the 111A plus class, we would refer to this as a multifunction device. The reason being is it is a switch, it is a router, and it has a wireless access point built into it. In the one pictured here, you can see the antennas, you can see the switch here in the back that has 3 or 4 connections for wired devices. This connects to our modem. This behaves as a router for our home. It may also do NAT, it may do DHCP, it may be a firewall, it may do port redirection. There's a lot of things that our home multifunction device can do. You can also have straight up access points. On the BCTC campus, in the classrooms and out in the hallways and the study areas, you may look up and see a white rectangular device. Those are wireless access points. You may have wireless access points in your home that you connect to your multifunction router. I don't do that anymore, but I used to have an Apple base station that I would connect to my Cisco device and use that wireless access point as opposed to the one that was built into my Cisco device. As far as access points, there are a couple of different types that we can have. We can have, let's see, make sure I'm not getting ahead of myself. Okay. So what they have here is autonomous access points, which basically the two defining characteristics are that are somewhat related is they're standalone devices and they're individually configured. So here in this graphic, we have a traditional wired network. We have an access point that's plugged into one of our switches and then is servicing some devices. Here they have a phone, a tablet, and a laptop. If you want to configure this wireless access point, you would administratively log into it, giving an administrator user ID and password, and then configure it. If we had a second autonomous access point out here, and we wanted to configure it, even if it was the same change, then we would log into that access point. Or we can have controller-based devices. So here we have a WLC, which is a wireless LAN controller, and it's doing link aggregation, where we've talked about link aggregation before, was in the module on Ether channel. And then what it can do is, by making configurations on the wireless LAN controller, it can then push out those configurations to your various access points. Wireless has antennas, and there are different types of antennas. A lot of low-end antennas are omnidirectional antennas, which basically mean they're going to cover approximately a circle. That circle can be interrupted. For example, if you have walls of a house or walls within your house or office building, it may distort that circle a little. We can have directional antennas by either phasing the antennas or having a reflector style antenna shown in the picture. We can kind of control what direction or general direction radio waves go and where we pick up radio waves. And then we have multiple input, multiple output antennas, which basically imply that we have multiple antennas that can work simultaneously. And the purpose is to distribute out over the communications over these different antennas, and therefore increase the overall bandwidth that you're providing to your end devices. 1227 is a check your understanding on the different components of a wireless LAN. So you can do that on your own, and we'll move on to wireless LAN operation. So this section 12.3 starts with another video. This video is 11 minutes and 50 seconds long, so I'm not going to play this here like I did the one in the previous section, but I do recommend that you go back on your own at home and watch that. So the first thing we're going to talk about here is different types of wireless topologies. And basically, when we have something called ad hoc, we just have two devices that are connected together. There's no access point. They're communicating together. This is very similar to taking a crossover cable and connecting two computers together. They can communicate with each other, but nothing else. The other thing or topology that we can have is referred to as infrastructure mode. Okay, and for some reason that is not coming up. Okay, there we go. So in infrastructure mode, you have a distribution system that has access points connected to it. So this is, for example, what we might have at BCTC, where we have a distribution system where all the wireless access provides, I think it's KCTCS or BCTC guest, and then a faculty staff connection. And then finally, you can have tethering, where you're using some device that already has its own internet connection, for example, shown here, a telephone, and then you can put it in hotspot mode or tethering mode and share out a wireless connection to a PC. And most smartphones these days will let you do that. The next thing we're talking about is BSS and ESS. BSS stands for Basic Service Set. When we talk about a basic service set, we're talking about a single access point and all the clients that are connected to that. When we talk about an extended service set, this is two or more basic service sets that are joined together. And then one thing they mention is a distribution system, sometimes called a WDS, a wireless distribution system, where you kind of extend the SSID, the service set identifier, or what most of us would think of as the name of the access point. Used to in my home, I don't need it anymore. I used to have 3 or 4 wireless access points that were joined into one wireless distribution system. So basically they work together to make it appear like there was one access point in the house, even though you might be connecting to one of the 4 or 5, whatever I had. Okay, when we're talking about layer 2, we have frames. So we spent some time in Cisco 1 and a little bit of time here in Cisco 2 talking about Ethernet frames. So here we're talking about 802.11 or wireless frames. So they have a header, a payload or data, and a frame check sequence, very similar to what we have in an Ethernet frame. However, the header is slightly different. So we have something called the frame control, which is going to tell the protocol, for example, and some security settings. We have the duration, which is a time that may be needed to receive the next frame transmission. And then normally we have a source and a destination address. In the case of a wireless frame, we have 3 addresses. Typically, address 1 is going to be the MAC address of the receiving wireless device, which is often an access point. Address 2 is going to be typically the MAC address of the wireless NIC of the transmitting device. And then sometimes there is the MAC address of the destination, which may be a router interface such as the default gateway. We have a sequence control that deals with sequencing and fragmenting of packets. We sometimes have a 4th address, which is only used in ad hoc mode that we talked about a moment ago. Then the payload is the actual data that we're trying to send. And then the frame check sequence is the layer 2 error control, just like we have a frame check sequence at the end of an Ethernet frame. Now, I don't know if we talked about it in Cisco 2, but we definitely talk about it in Cisco 1, which is we talk about CSMA/CD, and here we're talking about CSMA/CA. So, I tell the students to break these down 2 at a time. The CS is carrier sense, which means we're going to kind of watch the medium. In this case, the wireless medium is, the air around us, to see if anybody else is communicating. The MA is multiple access, whether we're on a wired or wireless network. We may have multiple devices that want to communicate with each other. And in the case of a wired network, we have /CD, which is collision detection. But in the case of wireless, we have collision avoidance. So there's actually a mechanism that tries to make sure, or does make sure, that collisions do not happen. Wireless LANs, one thing that we may not have seen yet in the curriculum, are half duplex. So anytime we have half duplex, that's when we have to worry about collision. So in the case of wired networks, we listen to the wire to see if there's a signal. In the case of wireless, we're going to look to make sure that there's nobody transmitting in our vicinity on the channel that we're on. We then send a ready to send message to the access point, basically saying, hey, I'm ready to send you a message. And there may be multiple people that send that at the same time or approximately the same time. But the access point is going to send to one of the wireless device is probably the first one it sees, a CTS, which is a clear to send. Basically, okay, I know you want to talk to me, you're clear to send. So if the wireless client does not receive a CTS, it's going to wait some random amount of time, and then it's going to send the RTS again. But one of the devices hopefully receives a CTS, and then it's going to transmit its data. And then the access point is going to acknowledge the receipt of that data. So by doing this handshake, we avoid collisions. There's no way that under normal operation, two devices could be trying to or carry on a conversation at the same time with the wireless access point. Or if they do, then the wireless access point takes one of those. So there are 3 steps for establishing communications in a wireless network. First, we discover there's an access point out there. Then we authenticate, if necessary, with the access point. And then we associate with the access point. So a lot of times this would be like on your phone or your tablet where the Wi-Fi symbol appears or there's a check mark next to the Wi-Fi, meaning that it's actually associated itself with one of possibly many access points that it can see. Okay, several things in this communications. The SSID is the service set identifier. Again, we're going to think of that as the name of the access point. We may need a password. Sometimes in wireless it's called a key to connect to the access point. We need to negotiate or be set to a particular standard that we're going to use, or a set of standards, and they will negotiate which one they're both able to use, typically the highest or the newest or best protocol. They'll talk about what type of security they're going to do, which is basically how are we going to encrypt messages, or are we going to encrypt messages between the end device and the wireless access point. And then typically we have channels. These may be hard-coded, set to a particular channel, or it may be set to auto. And again, the device that's trying to communicate with the access point and the access point will negotiate what channel they're going to communicate on. Another type of mode that we have to worry about is passive and active mode. So in the case of passive mode, basically the access point is going to broadcast its SSID. And what they're showing here is, periodically it'll say, hey, I'm out here. Here's the standards I support. Here's my security settings. Here's my name. So that's how when you go into some place like Chick-fil-A, and you go, I want to connect to the wireless, it says, hey, I can see an access point called Chick-fil-A guest. So that's because the devices are broadcasting that information. Compared to that, we have active mode, where the SSID or the name is not transmitted. And if you want to connect to an access point, you have to know it's there. You have to know its SSID. And you have to know what standards it supports and the password for it and that type of thing. 1238 is to check your understanding on wireless LAN operation, so you can do that on your own. And we will move on to CAP-WAP, which stands for Control and Provisioning of Wireless Access Points. There is a video here that's 3 minutes and 45 seconds, relatively short, so I'll go ahead and play that in line with the lecture.
Let's discuss CAP-WAP, Control and Provisioning of Wireless Access Points. CapWAP is an IEEE standard protocol that enables a wireless LAN controller to manage multiple access points and wireless local area networks. CapWAP is responsible for the encapsulation and the forwarding of wireless LAN client traffic between an access point and a wireless LAN controller. CapWAP is going to establish tunnels on the UDP ports 5246 and 5247. This is with IPv4 and with IPv6. CapWAP will also provide additional security with DTLS encryption, which is Datagram Transport Layer Security. A key component of CapWAP is the concept of split media access control. With this, we're going to have the functions normally performed by an individual access point distributed across two functional components. The first functional component being the access point MAC function. That's going to be handling the beacons and probe responses, packet acknowledgements and retransmissions, frame queuing and packet prioritization, and MAC layer data encryption and decryption. The wireless LAN controller function is going to be authentication, association and reassociation of roaming clients, frame translation to other protocols, and the termination of 802.11 wireless traffic on a wired interface. Next is DTLS encryption, the Datagram Transport Layer Security encryption. DTLS is a protocol that provides security between the access point and the wireless LAN controller. This allows them to communicate using encryption, and it prevents eavesdropping or tampering from those man-in-the-middle attacks. Now, DTLS is enabled by default to secure the control channel for CapWAP. This is disabled by default, however, for the data channel. What that means is all CapWAP management and control traffic exchanged between the access point and the wireless LAN controller is encrypted, and it's secured by default. However, data from the clients moving between an access point and the wireless LAN controller is not encrypted by default. CapWAP data encryption is optional, and it would be enabled per access point. It requires a DTLS license to be installed on the wireless LAN controller prior to being enabled on an access point. FlexConnect is a powerful wireless solution for branch offices and remote office deployments. This is going to allow you to configure and control access points in a branch office, which could be a remote office, controlling it from the corporate office through a WAN link, a wide area network. And you could do this without deploying a wireless LAN controller in the office with the access points. Now, there's two modes of operation for the FlexConnect AP, which would be the access point in the branch office. The first one is connected mode. In a connected mode, the wireless LAN controller is reachable. It's reachable across the wide area network. And with this, there is CapWAP connectivity where we can send traffic through the CapWAP tunnel, and the wireless LAN controller performs all the CapWAP functions like we discussed earlier with split MAC. In standalone mode, the wireless LAN controller is unreachable. The FlexConnect access point has lost or failed to establish the CapWAP tunnel with the wireless LAN controller. In this mode, that FlexConnect access point can assume some of the wireless LAN controller functions, such as switching client data traffic locally in the network and performing client authentication.
Okay, continue on talking about CapWAP again, which is control and provisioning of wireless access points. The main thing, kind of general information about it, is that it's not IEEE standard, and what it does is it enables a WLC, which is a wireless LAN controller, to manage multiple access points and a wireless LAN. So over here we can see that we have a wireless LAN controller. We have several access points, and CapWAP is a protocol that communicates back and forth between the wireless LAN controller and the different access points. One thing that we talk about is split MAC architecture, and what this does is it normally an individual access point performs on its own. So what happens is you're going to have access point MAC functions, which we'll talk about over here, and then we're going to have MAC functions of the wireless LAN controller. So basically on the wireless LAN controller, we care about authentication. But on the access points, we're going to be looking for beacons that are transmitting the SSID and looking for responses to probes we might send. The access point is going to acknowledge packets and or deal with retransmissions. It's going to queue and prioritize packets, and it's going to do encryption. And then what happens, these layer 2 things over on the access point, we're going to do frame translation to other protocols that may be coming over the wireless connection. And we'll deal with termination of 802.11 traffic onto a wired interface so that it can travel over the network. DTLS stands for Datagram Transport Layer Security. Basically what this means is data traveling between the access points and the end devices, or between wireless access points, is going to be encrypted. We also have FlexConnect access points. This is wireless across different or multiple locations. So basically we have an access point here that is connected through switches and routers to a different location. And we have the wireless LAN controller here. So we're communicating across a wide area network to deal with the configuration of access points. And for example, this may be a corporate office and this may be a branch office. So 12.4.6 is check your understanding on CAP/WAP operations. You can look at that and do that on your own, and we will move on and talk about channels and channel management. So one of the things that we have to deal with is channel saturation. And basically what channel saturation is that means the demand for a specific channel is high. And that's going to slow down performance. So one way that we can try to alleviate saturation and improve communications, or 3 of the ways, are discussed here. The first is DSSS, which is direct sequence spread spectrum. So basically what you do is you spread a signal over a larger frequency range. So instead of having this narrow bandwidth, we extend the bandwidth, the frequency that we're communicating with to try to improve bandwidth. The second is FHSS, which is frequency hopping. And what we're doing is basically multiplexing over different channels. So we're jumping around and using different frequencies. And the last is OFDM, which is orthogonal frequency division multiplexing. And basically you use multiple channels that are on adjacent frequencies. So frequencies that are really close to each other, you use multiple of those to send the signal out. So we have different channels, and what they're showing here is the 2.4 gigahertz range in North America. And what happens is we have channels 1 through 11, but this overlapping, if you have 2 channels that are close to each other, can cause some interference. So one thing that they do is notice that 1, 6, and 11 are kind of highlighted here in the graphic. And if you use channel 1, 6, and 11, there is no frequency or channel overlap at all. So a lot of times they will say you should build your network with channel 1, 6, and 11. The other thing you need to know about channels is if 2 channels overlap, for example, if we have 2 access points that are on, let's say, channel 6, even though that's been deemed one of those good channels. If they overlap each other in the overlapping of those two circles on channel 6, any device that is in that overlap will not communicate correctly. So this is kind of what I'm talking about. Let's say all these were set to channel 6. It's kind of football shaped here where we have overlaps. We would not be able to communicate within this overlapped area. But if we set it to 1, 6, and 11, these can overlap, and we do not have that problem. In the 5 gigahertz range, they kind of accounted for that by having non-interfering channels. So here they're showing the first 8 of those channels that will not interfere with each other. So what you can do is you can take, for example, in this case they've taken 36, 48, and 50, and 60, and use those together so we don't have any interfering channels. So that's channel selection. As far as planning a wireless LAN, what you need to do is first you need to go through and try to cover using circles and the least number of access points. So here, it looks like this building may have a lobby, and then it has some office areas that we're going to use 3 access points to cover. So that's the first thing you have to figure out. Then you have to figure out these locations you just kind of picked. Is there going to be a good place to mount the access point, and is there going to be electrical plugins there, or are you going to have to run those, and is there going to be wired connections to plug the wireless access points in? Also, there are different things that can interfere, fluorescent lights, wireless cameras, microwaves, cordless phones that use 2.4 gigahertz range, etc. Typically, it's best to set the access points as high as possible. Mount them to the ceiling. That way they're mounted above obstructions. You're going to want them where users are going to be expected, which would be like conference rooms. If you have seating in hallways or little study areas like we have at BCTC, office areas, so make sure you've covered all the important areas. If you have break areas outside, or picnic tables or things like that, and you want to provide wireless to those areas, you'll need to take those into account in addition to anything else that you might have to do. So that finishes up channel management. 12.5.4 is to check your understanding on that, and you can do that on your own, and we will talk about wireless LAN threats. So this video is 5 minutes and 41 seconds. I think I do want to play that here in line, so I'll go ahead and play that now.
As we dive into wireless local area networks, we need to describe the threats to our wireless LANs. And to get started, a wireless LAN is pretty much open to anyone within range of an access point. And if they have the appropriate credentials to associate with that access point, they are on the network. Now, these attacks, they can be generated by outsiders, disgruntled employees, even unintentionally by employees inside of your company. And they don't even have to physically enter the workplace to gain access to the wireless local area network. There's many different types of wireless attacks that can happen, one of them being interception of data. Your wireless data, it should be encrypted at all times to prevent it from being read by eavesdroppers, people who shouldn't have access to that data. Wireless intruders are unauthorized users that are attempting to access network resources, and you know what? They can be deterred by using authentication. Denial of service attack is a little more difficult. They try to access your wireless local area network services then compromise them either accidentally or on purpose. We also have our rogue APs, which are unauthorized access points that are installed by either a well-intentioned user, someone just wanted to have an extra wireless network close by, or installed for malicious purposes, and they want to be able to intercept people's traffic. Using management software, we should be able to detect those rogue access points. How do denial of service attacks happen on wireless? Well, they can happen because of things like improperly configured devices. Configuration errors can disable a wireless network. For instance, an administrator, they could accidentally disable the network with a disable button. Or even an intruder with administrator privileges could intentionally disable the wireless local area network. Now, another DOS attack is where a malicious user intentionally interferes with the wireless communication. What that means is a malicious user has a goal, and their goal is to overwhelm the wireless access point to such a point where no legitimate devices can access it. There's tools for mobile devices for this, as well as specific radio frequency blocking tools. Accidental interference, we all know what can happen. Our wireless local area networks, they're prone to interference from other wireless devices. And these devices can be things like microwave ovens, baby monitors, cordless phones, and even more. The 2.4 gigahertz radio frequency, that is the most prone wireless band for interference. So how do we minimize this risk to denial of service? Well, we're going to harden our devices and keep our passwords secure. We're going to use backups in order to come back online as fast as possible. And also, any changes that we're rolling out on our network, they should always be done off hours, not during a production environment time frame. A lot of this interference that can happen, as mentioned, is on the 2.4 gigahertz band, so let's move our devices to the 5 gigahertz band if it's possible. Rogue access points are the detriment of wired network security. A rogue access point is an access point or wireless router that has been connected to a corporate network without the explicit authorization of the company. This is completely against company policy. Anyone with access to the physical premises can install a very inexpensive wireless router or access point and allow themselves access to the secure wired network resource. Once connected, these rogue APs can be used by an attacker to capture MAC addresses, to capture data packets, and even to gain access to wired network resources. They can be used to launch man-in-the-middle attacks as well. To prevent the installation of these rogue access points, organizations have to configure wireless LAN controllers with rogue AP policies, as well as they should use monitoring software to actively monitor the radio spectrum for unauthorized access points. With a man-in-the-middle attack, a hacker is going to position themselves between two legitimate entities in order to either read or modify the data that passes between those two entities. Now, there's many ways that a man-in-the-middle attack can be created. A popular way is to use the evil twin access point attack. And this is where an attacker is going to introduce a rogue access point. They're going to configure the rogue access point with the same wireless SSID as a legitimate real access point nearby. Locations offering free Wi-Fi, such as some coffee shops and airports and restaurants, they're popular spots for this type of attack to occur because they usually have open authentication. With open authentication, a password is not needed when you're going to access the wireless network. Now, connecting wireless networks would see two access points offering wireless access. The people near the rogue access point would find the stronger signal and probably connect with it. Once that user traffic is sent through the rogue access point, that data is captured and then it's usually forwarded to the legitimate access point. The traffic returning back from that legitimate access point will then be sent backwards to the rogue access point. It's going to be captured by the malicious user and forwarded out to that poor, unsuspecting user. This allows the attackers to steal user passwords, to grab personal info, and to even gain access to the user's device. Defeating these man-in-the-middle attacks depends on the sophistication of your wireless local area network infrastructure and also the vigilance that you use to monitor activity on those wireless local area networks. It all starts with identifying legitimate devices on the network. And after you have the legitimate devices being known, the network can be monitored for anything that looks abnormal.
Okay, let's talk about some of these threats. The first one is a security overview for wireless networks. We have a lot of the same security issues that we talked about and worry about in a wired environment, but the problem with wireless is you don't actually have to be connected to the network. You don't have to find a jack or a networking device to plug into. And even in a lot of cases, you can be outside. For example, if you wanted to hack somebody, you can maybe pull up into a loading dock or even into a parking lot and be able to mess with or intercept their wireless connections. So there's several things, attacks that we worry about. The first is an attacker trying to intercept data. So basically, they want to eavesdrop on your communications and try to get personal, confidential information, trade secrets, that type of thing. We can have wireless intruders, which are unauthorized users that are trying to log into our wireless devices or our infrastructure. Just like in wired networks, we can have denial of service. The purpose of that attack is to cause something, maybe the access point not to function correctly, or maybe you're attacking a server within an organization and you're doing that from their wireless. And then you can have rogue access points, which are unauthorized access points that are placed on the network for various malicious reasons. So a denial service attack can happen by devices that are not configured correctly. You can go in and you can disable a WAN if you have the administrator password, for example, or you can turn off the DHCP server or add firewall rules, all kinds of malicious things. You can try to interfere with an access point's normal operation so that they cannot talk to wireless. And you can also have an accidental denial of service where, for example, your purchasing department finds a really good deal on 2.4 gigahertz phones because they can buy a phone for $10 and it has a wireless headset and give that to all the employees, and then that's going to wreak havoc on any 2.4 gigahertz wireless that you have around. So that might be an example of accidental interference. Again, a rogue access point is an access point that is placed on your network. Here they're showing some security policies. Unfortunately, they don't have an enlarge button, so I'm going to have to use the accessibility features of my Mac. Actually, it looks like it might have given me the enlarge cursor. But here they're trying to detect rogue access points and remove rogue access points from the networking is what they're trying to show you there as far as the policies. Man-in-the-middle attacks, we've talked about those before. Basically where you try to insert yourself in the middle of a conversation. You can do that a couple of different ways, but one way is to have software and mimic an access point, broadcast the same SSID as a valid access point, and this is called the evil twin. So what would happen is you would intercept that communications and then possibly forward them on to the correct location. So if you go to a conference or stuff like, I used to go to Macworld and Apple's Worldwide Developer Conference, and, there might be an access point, somebody will put out their WWDC guest or, free WWDC wireless, trying to get you to connect to that access point by fooling you with the name, or as in the case of the evil twin, actually using a valid name to try to intercept data. So 1266 is a check your understanding on the different types of wireless LAN threats. You can do that on your own, and we will move on and talk about how you try to secure your wireless LAN from these different types of threats. So this section starts off with a video. It's 7 minutes 9 seconds long. I won't play that here in line. You can watch that outside of class, but we'll go ahead and talk about some of the things. So one thing they talk about is SSID cloaking, or basically disabling the broadcast of the SSID. Might be a little easier way to understand that. So you're not going to be able to, say I want to connect to a wireless network and see a wireless network that has the SSID disabled. But don't let this fool you. This is not super secure. Every packet that goes between the wireless access point and your wireless device, or a wireless device, has the SSID in there. So I have software on my laptop, software on my phone, that will actually show you all the access points that are operating in the vicinity, regardless of whether they're broadcasting their SSID or not. So this is probably the weakest form of security. Now, one of the best forms of security is the second thing they talk about here, which is MAC address filtering. So basically what MAC address filtering does, if you enable it, is you say, here's a list of MAC addresses. In this case, there are 2. These are the only 2 machines that are allowed to communicate with me. Now, there are ways to impersonate these MAC addresses which can circumvent this, but this is pretty good security. The disadvantage is if you're doing this at home, for example, and somebody comes over and wants to use your wireless, you have to go, well, they go, I can't connect your wireless. And you're like, oh yeah, I need your MAC address. And they're like, okay, what's that? Well, open up the MS-DOS command prompt. Okay, what's that? Okay, once you get them on, now you need to do IP config/all and find the MAC address, and then you need to go type it into this list. Or if you replace your laptop or your cell phone, you will have to enter it. If you get a TV that uses a wireless connection to download and run apps like Netflix, you will need to get the MAC address of the TV and program it into your router. So it is secure, but there's some disadvantages associated with it. There are different types of authentication modes. A lot of them, if you're out at public, like at Lowe's or Walmart, Chick-fil-A, restaurants, is open. That means it doesn't require a password. Any client can associate with it. And then if you want to be secure, the client has to deal with things that might go on relating to hacking. More secure is shared keys. So you can think of this key as a password. And we have different types of shared key authentication methods, which are talked about here in a moment. But WEP, WPA, WPA2, and WPA3. WEP is wired equivalency privacy. When they came out with this was the first encryption related to wireless, and they wanted to try to make it as least as secure as if you were on a wired connection. That's why it's called wired equivalency. This is not recommended because it's pretty easy to hack. You can relatively quickly, if you have the right tools, figure out what the password is for an access point and then do that. If you have like an Onoco card that you can interject bogus packets into the network and then receive them back on your quote normal wireless, you can hack into a WEP network very, very quickly doing that. So then they came out with WPA, that has, the stuff that sounds like it's from Star Trek, temporal key integrity protocol. Basically, temporal is time. So over time, the key changes, and specifically for WPA, after every packet, the key rotates or changes. WPA2 then came out. It uses advanced encryption standard, so a little stronger encryption. This is the current standard, and WPA3 is being developed, but this disallows the older, less secure protocols, and it uses something called protected management frames. So it's going to be more secure than WPA2. But like they say here, they're not readily available at this point, but they're coming. 12.7.5 is talking about authenticating a home user. There are two different WPA methods. There's the personal method, which is intended for home or a small office. They use a pre-shared key, so basically a password, or you can set it to WPA2 Enterprise, which requires something like a Radius server or a TACX server to actually do the authenticating of the user. So the access point passes off the yes/no. This user should be able to authenticate to, for example, the Radius server. We mentioned both of these before. We have temporal key integrity protocol and advanced encryption standards, which are pretty strong encryption that might be used on a wireless access point. Here they're showing you an example of where you can go through and pick. If your devices and your wireless access point are all able to do AES, that's probably going to be the preferred method. Here they're showing if you're doing enterprise authentication, for example with WPA2, you still can specify the type of encryption. You can give the IP address, so 10.10.10.100 is a Radius server that we're going to talk to, and the pre-shared key or the shared secret with the Radius server is this kind of random looking things, and then you can tell how often you want to renew the key. So that's going through, that's setting it for 2.4 gigahertz. Oftentimes you would go and set the exact same thing up for your 5 gigahertz connectivity. WPA3 also has a personal and enterprise methods. So if it's set to personal, basically a hacker can listen to the handshakes and try to break in. However, the pre-shared key is never transmitted, so it would be very difficult. They say impossible, but very difficult for a hacker to guess. If we're using WPA3 Enterprise, basically we're going to use 192-bit cryptography suite, which is pretty strong encryption. So that would be for high security. You can set it to open networks. So basically this would be unauthenticated traffic. And then down here we have Internet of Things onboarding, which uses Wi-Fi protected setup. You have to be a little careful with this. For example, if somebody comes in and is putting a DVR and wireless streaming devices, like for example DirecTV, A lot of times what they want to do is push the WPS button on your router, which will allow devices to connect for some period of time, like a minute or two, and configure themselves without having to use a password. And it generates a random password, which is fine and dandy for the quick setup of those devices. However, if you have laptops or desktop machines that are currently using your wireless network, they no longer have the password, and it can be a challenge for you to figure out what the password actually is. But in the case of Internet of Things, you may have lots of devices that you want to easily connect. 1279 is a check your understanding on securing wireless LANs. So we'll move on to the module practice and quiz. So here's a list of what did I learn in this module, so you can read over that and make sure you understand all the things. If you want to test that knowledge, 1282 is the module quiz over the entire module, Wireless LAN Concepts, so you can take that. And that finishes up the Module 12 lecture.